Hello students, today we discuss about the non-homogeneous linear differential equations of second and higher order with constant coefficients. Here contents of this topic today presentation is objectives, introduction and operators D and D inverse and properties of the polynomial operators. Non-homogeneous equations of higher order and determination of particular integrals. And another last topic is a variation of parameters method. Summary. Now in these contents it is most important is a non-homogeneous differential equations of higher order and its solution finding. Here previously homogeneous differential equations, here there we identified that complementary solution. Here non-homogeneous right side term solution also we should identify, that is called as a particular integral. Now complementary solution and particular integral both is called as a general solution, both will add general solution. Now variation of the parameters method is the last topic. Now here objectives of this problem is comes to the here particular integral of the given non-homogeneous second order linear differential equation with constant coefficients. By using the differential operators we can be identify the general solution. That is whenever there another particular integral we can identify using the variation of the parameters method for the non-homogeneous second order linear differential equation with constant coefficients. This is the objectives of today study. Now it is a introduction part. If we discuss previous knowledge on this unit, it is a nth order linear differential equation with constant coefficients. Here differential equation have the form of it is a a0 into d power n y by dx to the power of n plus a1 into d power n minus 1 y by the dx to the power of n minus 1 plus a2 into d to the power of n minus 2 into y by dx to the power of n minus 2 plus so on plus an minus 1 into dy by dx plus an into y equal to q. Now example, if I take that it is a left sided term is dqy by dx cube plus 3 into d square y by dx square minus 6 into dy by dx plus 2y, and right side term is equal to sine 5x. Right side term will give that is a particular integral. It means that sine 5x with the inverse operators will give that is a particular integral, and the left sided term it is a operator form f of d into y give that is a equal to 0 gives that is a complementary solution. Now complementary solution is gives that is a left side term and a particular integral gives a right side term. Both is total is called as a general solution. Now in this differential equation, how operator form will be decided? It is a left sided term f of d into y is called as a equal to 0 is called as a operator form. F of d, what is the f of d for this operator form? It is a d power n y by dx to the power of n. It is a d by dx is a capital D that we studied into the homogeneous linear differential equation in the previous units. So that it is a d by dx equal to d if I use, it is a a0 into d power n plus a1 into d power n minus 1 plus a2 into d power n minus 2 plus so on plus a n minus 1 into d plus an is called as a f of d, that is called as the operator form. Now it is a dq y by dx cube plus 3 d square y by dx square minus 6 dy by dx plus 2y equal to sine 5x. It is a order 3 linear non-homogeneous linear differential equation example. So here dq y by dx cube plus 3 into d square y by dx square minus 6 dy by dx plus 2y equal to sine 5x. If I take this example, here operator form is dq y plus 3d square y minus 6 dy plus 2y equal to sine 5x. Why you take the common from the left side term? It is a dq plus 3d square minus 6d plus 2 into y equal to sine 5x. Left side term f of d into y equal to sine 5x. What is f of d? F of d equal to dq plus 3d square minus 6d plus 2. This left side term will give that is a complementary solution of the linear differential equation. Next right side term sine 5x is gives that is a particular integral. Now here particular integral case, it is a function x which satisfies the linear differential equation. F of d into y equal to q is known as a particular integral. Complementary solution case, here q equal to 0. So here first complementary solution definition, it is a function x which satisfies linear differential equation f of d into y equal to 0. So whichever the solution satisfy f of d into y equal to 0, that gives that is solution is called as a complementary solution or complementary function. Now particular integral right sided term whichever is there that satisfy that is a differential equation with the right side term q of x is exist, that is called as a particular integral. Now general solution means it is a complementary solution plus particular integral is called as a general solution. Now suppose f of d into y equal to q. How do I solve? Means it is a complementary function f of m equal to 0. F of m equal to 0, it is a differential equation. D instead of d we substitute m. That is called as a auxiliary equation. Auxiliary equation means it is a d equal to m we substitute. So a naught into m power n plus a1 into m power n minus 1 plus a2 into m power n minus 2 plus so on plus a n minus 1 m plus a n equal to 0. Now this is gives that is a nth order linear differential equation, so that we get that is a n roots. From that it is a already we have a roots are real and distinct, roots are real and equal, roots are complex. Then we can apply that is a solution procedure we studied into the homogeneous linear differential in the previous units. So that here same procedure finding of complementary solution, we use the same methodologies. So dqy example, if I take dqy by dx cube plus 3 d square y by dx square minus 6 dy by dx plus 2y equal to sin 5x. Here left side term operator form, if I write dq plus 3d square minus 6d plus 2 into y equal to sin 5x. That is a f of d into y equal to sin 5x. F of d equal to dq plus 3d square minus 6d plus 2. Now auxiliary equation is a instead of d we substitute m. So f of m equal to 0 for finding of the roots. M cube plus 3m square minus 6m plus 2 equal to 0. This is a cubic equation. So cubic equation if we solve by using that is a complementary solution process, we can identify the complementary solution. Now general solution means it is a complementary function plus particular integral. Now here complementary function f of d into y equal to 0, left side term will give that is a complementary solution. It is a determination point of view. We use that f of d into y equal to 0. Auxiliary equation we write f of m equal to 0. After writing auxiliary equation we find out the roots m1, m2 so on mn. Here we have a n roots. Then here roots are real and distinct, roots are real and equal, roots are complex. Such a way we have that is a various cases. Here complex is a case 2, here real and distance. Such a way here we can identify the solution. That we studied in the previous unit, same process we can identify that is the complementary solution. Now here solving the following the differential equation. What is that? dqy by dx cube minus 3 dy by dx plus 2y equal to 0. Now here f of d into y equal to 0, so that it is a we can write a d cube minus 3d plus 2 into y equal to 0. It is a left side term. Auxiliary equation I can write that it is a, if I use that d cube, it is a m cube minus 3m plus 2 equal to 0. Now I will write that is a solutions are m minus 1 into m plus 2 equal to 0. Roots are 1 1 minus 2. So here two roots are equal, one roots are distinct. So that complementary solution is c1 plus c2 x into e power x plus c3 into e power minus 2 into x. Now another example, if I take for finding of complementary solution, example is a d power 4 minus 2d cube minus 3d square plus 4d plus 4 into y equal to 0. Here auxiliary equation is a f of m. So m power 4 minus 2m cube minus 3m square plus 4m plus 4. Now this roots identified, it is m plus 1 whole square, m minus 2 whole square equal to 0. Here roots are m equal to minus 1 and 2 and 2. Here two roots are the equal minus 1, another two roots are equal 2. So that it is a complementary solution. Because of fourth order we will have a solution of a 4 constants. So here yc equal to c1 plus c2 x into e power minus x, that is the first equal root solution, plus here another equal root solution, root is a 2. So c3 plus c4 x into e power 2x. This is a solution of complementary solution of the given differential equation. Next example 3, if I take, it is a d power 4 plus d power 4 plus 8d square plus 16 into y equal to 0. This we can write m square plus 4 whole square equal to 0. So m plus 2i whole square, that is the auxiliary equation. So m plus 2i whole square, m plus 2i whole square equal to 0. So what are the roots here? M plus 2i equal to 0 and m minus 2i equal to 0. So here 4 roots I will get, m 2i minus 2i. So that here e to the power of 0 into x, c1 because of alpha is 0. Here 2 is a complex root, another is a minus 2 is a complex root. So that it is a e power 0 into x into c1 plus c2x into cos 2x plus c3 plus c4x into sin 2x. Now another example 4. It is a y double dash plus 6y dash plus 9y equal to 0. Here in this example, I am taking the initial condition y of 0 equal to minus 4, boundary condition y dash of 0 equal to 14. Now f of d into y equal to 0, so d square plus 6d plus 9 into y equal to 0. Auxiliary equation is m square plus 6m plus 9 equal to 0, m equal to minus 3 minus 3. So y equal to c1 plus c2 x into e power minus 3x. Now in this equation yic means y of x equal to 0. Here he has given the y of 0 equal to minus 4. If I substitute that, here I will get that is a one of the equation y of 0 equal to minus 4. If I substitute c1 equal to minus 4 and the derivative you take y dash of 0 equal to 14. Both are the derivatives. If we substitute, then we can get c1 and c2, solving of these two. So c1 c2 identification point of view, initial conditions they will give y of 0 equal to minus 4, y dash of 0 equal to 14. Now y equal to minus 4 plus 2x into e to the power of minus 3 into x. This is called as a complementary solution. Now solving of that, another example, if I go further, it is a 4 into y triple dash plus 4y dash plus y dash equal to 0. Here complementary solution 4m cube plus 4m square plus m equal to 0. M we take the common. Then 4m square plus 4m plus 1 equal to 0. So m into 2m plus 1 whole square equal to 0. M equal to 0 and here another roots are minus 1 by 2, minus 1 by 2. So y equal to c1 e power 0 into x. So that c1 plus c2 plus c2 c3x into e to the power of minus 1 by 2 into x. This is another solution. Here complex solutions if we get in the example 6, it is e to the power of minus 3 by 2 x into c1 cos root 7 by 2 x plus c3 sin root 7 by x. Here operator forms, it is a d and d inverse. Here d means it is a differentiation, d inverse means 1 by d, it means that is an integration. So that operations we will be used into the particular integral, so that it is a d power minus 1 into sin x. If I take 1 by d into sin x integration is minus cos x. Similarly here I will take that is a d power minus 3 into x square. So d power minus 2 into x cube by 3, 1 by d 1 I did. Then another d square d to the power minus 2, d power minus 1 into, this is x cube integration x to the power 4 by 4, 4 into 3, 4 3 is 12. So d power minus 1 into x to the power 4 by 12, 1 will be reduced because of I am doing the integration. Next d power minus 1 if I apply 1 by d integration. So x to the power 5 by 5, 12 5 is 60, so that x to the power 5 by 60. So inverse operators we will be apply like this, and whenever we want to the differential means it is a d cube x to the power of 6 means it is a we go for the derivatives only, directly we can get answers. Now here non-homogeneous equations of linear differential equations of higher order and its particular integral derivatives. We have a various methods. Here particular solutions, it is a type 1. Type 1 will go for that particular integral only. I am calculating complementary solution, previously we identified. So general solution is a complementary solution plus particular integral. Here homogeneous will take only the complementary solutions. Here non-homogeneous differential equation. So the particular integral we want to be identified. Here particular integral is a type 1. Type 1 we will go for that. It is a particular integral f of p of d into y equal to b x to the power of k. That is a algebraic term is having the right side. It is a b x to the power of k. Now particular integral case, it is a left side term p of d will come to the denominator of right side. So b x to the power of k by f p of d. Here whichever the constant term will be there, constant term 1 minus f pi of d whole power minus 1 aspect coming of that we will take the common. In that common is a naught into d, if I take common 1 minus f of d, that is a 1 by a naught into d power r, if I take 1 minus f of d whole power minus r into b into x to the power of k form. So left side p of d will come to the denominator, then denominator term is a we can write as a 1 plus pi of d form, that we take into the numerator form 1 plus pi of d whole power minus 1. That expansion after that, it is a wherever we have a derivatives directly d means a derivative we will be apply. After that we will go 1 by d will be there, means 1 by d means integration we should be apply. This procedure is called as a type 1 for particular integral finding. Now here that continuation of the simplification, here b x to the power of k divided by d minus a naught will be there. Here a naught means one constant, something a k means it is a, I will take minus a naught is a constant. It is a naught will come to the denominator 1 minus d by a naught whole to the power of, if I take numerator whole to power minus 1. That expansion is a, here minus into power is minus 1 and inside also minus, minus into minus plus, all terms are the plus. So that it is a right side I have given the formulas. Whenever we have a 1 minus d whole power minus 1, Here power is minus 1, inside is minus, minus into plus, minus into minus, plus. So all terms are the plus. So in same simplification we can get it is a constant is a we have taken the common, that is minus a naught. So that 1 minus pi of d whole power minus 1 expansions, these are the expansion we can use. 1 minus d whole power 2, 1 minus d whole power minus 2 means it is a 1 by d, that is a minus into minus plus 1 plus 2d plus 3d square plus 4d cube, so on. Similarly 1 minus d whole cube will be there, 1 minus d whole cube, that we will go for the numerator 1 minus d whole power minus 3, minus into minus plus. So that 1 plus 3d plus 3 6d square plus 10d cubes plus so on. The derivative terms I will be used in this. Right side is a function variable algebraic term will be there, that will be multiply, then derivatives of algebraic we can be used. This is a particular integral type 1. Now here example if I take that, it is a here left side auxiliary equation I will write m square plus m plus 1. It is a minus 1 plus or minus root 3 I by 2 is the roots. So that e to the power minus 1 by 2 x into c1 cos root 3 by 2 x plus c2 sin root 3 by 2 into x. That is a complementary solution over. Particular integral, it is a, that is I will take into the denominator term, which is the left side operator form. So yp equal to 1 by p of d into here right side is a x square will be there. So that it is a right side x square x cube, whichever is the term I will take. Then after that, it is the operator form I will take into the numerator 1 plus d square whole power minus 1. Here d plus d power square is a clear, it is pi of d. So 1 plus pi of d whole power minus 1, that is a formulas I gave in the previous slide. So that same expansion I will do. Because of inside is a plus and power is minus, plus into minus minus. So alternative terms will be take the one is plus, another is minus, plus and minus like that. So pi of d is the term will be there. Then right side whichever the term is there, that is a inside if we take each term, that we will be taken to the product form. So I can get that is a x cube minus 2x, it is a particular integral. Therefore complementary solution plus particular integral is called as a general solution. Now if I go for that, it is a second one is another example, d cube y by dx cube minus 3 minus dy by dx equal to here x cube plus x plus 1. Here auxiliary equation is a m square minus m cube minus m equal to 0. So m into m minus 1 into m plus 1 equal to 0, and its roots are 0, 1, minus 1. So that complementary solution c1 e power 0 into x plus c2 e power x plus c3 e power minus x. Now it is coming to the particular integral. What is the algebraic term? We will have right side, that is the left side operator form come to the denominator. In that minus d, I want the constant term 1 plus pi of d form. So that here minus d if we take the common, then I can write that 1 plus pi of d form. So minus d I took the common in the denominator, there I will get that 1 minus d square, that will be going to the numerator 1 minus d square whole to the power of minus 1. That expansion will go for that minus into minus power is minus and inside is a plus, minus into plus, minus into minus plus. So that all the terms are the plus 1 plus d square plus d cube plus so on, and algebraic term. Then if we multiply and after multiplication derivatives you take, then after you go for the integration, that is a particular integral we obtain. So solution is a yc plus yp. Next particular integral, particular solution, particular integral solution, both are the same. Solution name, another name is called as integral. Particular solution is it is a type 2. Now if we go for that, p of d into y equal to e to the power of mx. So here I will take that is it is a substitution e to the power of mx, here d equal to m we will substitute. Whichever the power term is e to the power of ax, if I take power x coefficient is a, so that a we will substitute. So here 1 by b into e to the power of x by p of a, here power coefficient e to the power of ax will be there, x coefficient, that coefficient we will substitute in the denominator. If the denominator is not equal to 0, directly we will take that is called as a particular integral. Example, if we take that right side, whichever is there, it is a d square y by dx square plus y equal to, this is the example. Now in this example, here 3 into e power minus 2x, it is a denominator, it is going on that, it is a 1 plus d square. So that directly d equal to what is that? Minus 2, because of e power minus 2x. X coefficient is minus 2, minus 2 I will substitute. Coefficient 3 will be there, keep it as it is, 3 into d plus only you substitute minus 3. So minus 2, so that it is x coefficient minus 2 whole square plus 1. So simplification I will get. That is called as a particular integral. Because of it is denominator, after substitution is not equal to 0, that is called as a particular integral type 2 case 1, not equal to 0 case. Next, because of right side is exponential, previous one is a algebraic term is the right side. Now in this denominator is equal to 0. There we will be used that is a solution is x to the power of r by r factorial into rest of the terms. How many terms are become 0? For example, it is a yp, I am taking his case to case, directly I will take here d minus a whole power r into p1d. If I take, that is a p of d, left side into y equal to here b into e to the power of x. What happened? It is a yp, left side term operator form come to the denominator. So it is a yp equal to d minus a whole to the power of r into p1d into b into e to the power of mx. So here how many terms are the 0? If I substitute a is a substitution, a minus a 0 power r times it will become 0. So that I will use that x to the power of r by r factorial. For that 1 by d minus a whole power r over, because of directly I am writing in the formula. What is that? E to the x to the power of r by r factorial. Then b into e to the power of mx is the same. Rest of the term p1 of d is non-zero term. So that it is a directly I will substitute a, because of it is a case 1 case directly I will apply. But it is a whichever how many terms are zeros, that will take the x to the power of r by r factorial. So example, if you see that left side, it is a here denominator term d plus 1 whole square, d minus 1 whole square, e to the power of x. Here x coefficient is how much? 1. 2 terms it is a become 0 because of d minus 1 whole square in the denominator. So there I can use that x square by 2 factorial into here directly substitution. What is that? It is a non-zero terms I am substituting. E power d plus 1 place is a 1 plus 1 2, 2 square 4, already x square by 2 factorial. So 2 factorial means 2 into 4 8. So x square by 8 into e power x. That is a example for identify the particular integral case 2 whenever it is a denominator terms are 0. In this case 0 terms will take separately, non-zero terms separately, we bifurcate that operator form. It is a 0 case operator forms are the directly x to the power of r by r factorial, and non-zero terms will be directly go for the substitution. This is a exponential term, it is a type 2 case. Here first type 1 is a algebraic case, it is a denominators will be taken to the numerators, 1 by d class operators will be integration, d means differentiation for the algebraic terms. Now it is exponential case, directly we apply for that, it is a left side term. It direct substitution means directly you substitute, that is case 1. Non-substitution will become 0 case, it is a how many are zeros? Operator terms, and non-operator terms, non-zero terms operators will be separate, and then you substitute. It is a 0 case, it is x to the power of r by r factorial. Next it is a non-zero case directly substitution. This is a case type 2 case 2. Now particular integral case 3, it is a we go for that is a trigonometric functions case. It is a trigonometric functions case. Here L of y equal to q of x form, that is a linear differential equation with the constant coefficients, non-homogeneous because of right side term will be there. Right side term is I am taking the trigonometric functions, sin bx or cos bx like that. If I take into the sin bx or cos bx into the right side, it is the same way, y equal to, it is a right side term divided by operator form. In this d, previously e to the power of x case, d equal to a we substituted. In this right side trigonometric case, it is a d square equal to minus of what is the coefficient of sine. Sine coefficient is a sine ax if I take minus a square. Minus is a mandatory. It is a d square plus is a we substitute minus a square because of sine ax. Sine 2x will be there, minus 2 square is a 4, minus 4 you substitute d square plus. So that is a substitution. If it is a, here also 2 cases, it is a not equal to 0, directly that is only the answer. Example I am taking to the right side, it is a here sine 2x, sine 3x if I take, it is a sine 3x divided by d square minus 3d plus 2. What happens here? D square equal to minus b square, minus 9 I am substituting. If I substitute minus 9, it is at minus 9 minus 3d plus 2. So that it is simplification is minus 1 by, it is a 3d plus 7. Next it is a 3d plus 7, it is a numerator and denominator we multiply 3d minus 7. It is a 3d minus 7 if we multiply, it is a a plus b into a minus b form we get into the denominator, means it is a d term we converted into the d square form. So it is a rationalization we did. So minus 1 by 3d plus 7, it is a rationalization we go for that, 3d minus 7 you multiply numerator and denominator. So that 3d plus 7 into 3d minus 7, it is a 9d square minus 49. 3d minus 7 into, so that it is a directly it is a d square we substitute, it is a minus 130 is a denominator, numerator d will be there, so that it is a multiply d each term, then it is a d means a derivative you should take. So we can simplification over. So it is a, whenever that it is a substitution is a d square equal to minus b square substitute, whenever we have a some more d terms, we go for the rationalization, it is the denominator is a convert into the d square form, and then d square equal to minus b square same value you substitute, then whenever we have a numerator d, so go for the derivative, then it is called as a particular integral, particular solution of type 3, whenever it is the right side is having the trigonometric function. Next it is comes to the here, it is a right side is a denominator has become 0. Their case we go for that is a fractional fraction, it is a complex form of separations we do. It is a d square plus a square we have. What we do, d plus ai into d minus ai. There we should take the sin ax means imaginary part of e to the power of ax we use. Because of sin ax, e to the power of ix plus e to the power minus ix by 2i. So that it is a imaginary part of e to the power of ix I will use. Next it is a b will be the, here simply we can remember the direct formula also. What is that? Minus b into x by 2a into cos ax. X by 2a into cos ax. Sin ax is a, we can write it is a x by 2a into cos ax. So here directly, otherwise we can be use this procedure also. What is that? B is a constant, you take the common. Here imaginary part it is a d equal to, what is the exponential form will be there, same procedure we can apply. How many terms are become, then we use that x by x to the power of 1 by 1 factorial into, then we go for the substitution. Similar substitution if I use, it is a simplification of that x by 2a into sin ax minus I into x by 2a into cos ax. In that imaginary part is a second term, so that it is a minus x by 2a into cos ax. I coefficient is the imaginary term. So constant is minus b will be there, and imaginary part is minus x by 2a into cos ax. Whenever the sign will be there, sin ax, so we use that it is x minus x by 2a into cos ax. This is a whenever it is equal to 0 form. It is a type 3 case 2. Next it is a, I am going for the example. Here cos x into cos 3x. Here 2 cos a cos b. What we can write? Cos of a plus b plus cos of a minus b. Then 1 by divided by 2. So that I use the same formula, so that I can get the d square plus 4 into y equal to 1 by 2 times of cos 2x plus cos 4x. Now here cos 2x, it is a left side complementary solution is a c1 cos 2x plus c2 sin 2x. Previously we did same procedure. Here right side term, it is a denominator will come to the operator d square plus 4 into the denominator. Next to separate the terms. Here whether it is a 0 case or non-zero case, first it is a 4 square minus d square equal to minus 4 square minus 16. If I substitute, first term is non-zero. Second term is a minus b square minus 16. If it is a big 0, it is a plus 2i and minus 2a I will use separating minus x by 8 into sin 2x directly I will get this particular integral. So it is a first term will go to the case 1, second term will go to the case 2. Next particular integral of the 4, case 4. What is that? X into v of x. X into v of x, x into trigonometric function, x into exponential function. Exponential function will be there. First case if I use exponential function. Algebraic it is x into v means it is a x into sin x, v equal to sin x. There I will use x minus x by f of d into v minus here second term p of d by p dash of d whole square into v. So that there we can be take the separations. It is clearly x minus pi dash of d by pi of d into v by pi of d. That is the formula for that, it is the algebraic term. Here pi of d is called as a p of d. It is a inside if we send, we get that is x into v by p of d minus p dash of d by p of d whole square into v. Now that is a product of x into v. V is a trigonometry function. Second case is comes to the e power ax into v. E power x into v. V is a, here e power x means directly d equal to d plus a I will substitute. Then whichever the exponential term will be there I will use. So e to the power of ax into v case, it is e to the power of ax is a d equal to d plus a if we substitute exponential function particular integral completed. Next whichever the term will be there v, that v is a algebraic term, that I will do it simplification. Previously it is x into v, here x e power x into v. V is the we will do second next term, that is the case 2. This is called as a operator form of the particular integral of 4. What is the particular integral of 4? V into p of x, v into x into v form, otherwise e power x into v form. Next here y double dash plus 4y equal to x into cos x. If I take that, it is the same procedure I will apply. X into, first is a x minus v by x into v by p of d minus p dash of d by p of d whole square into v. So separating the terms, general solution is a complementary solution and particular integral. This is another example, complementary solution plus particular integral e power ax into cos bx form. E power x means it is a d equal to d plus a we substitute, then cos x we apply, d square equal to minus b square, then we can get the particular integral. Now variation of the parameters, it is a particularly here already complementary solution, what we will get c1 into pi 1 plus c2 into pi 2. So here yp also c1 place we will be identify integral minus pi 2 into right side term q of x into Wronskian determinant of w of pi 1 comma pi 2 into d of x plus pi of 2 into integral of pi 1 into q of x by the Wronskian determinant of pi 1 pi 2 into d of x. Here c1 is a first integration integral minus pi 2 case and c2 is a integral of pi 1 case. So separately we will do and substitute, that is called as a particular integral. So that it is method is called as a variation of the parameters method. So here c1 instead of that we will be identify in the particular integral of minus pi to pi of x by Wronskian determinant dx plus c2 case it is integral pi 1 into pi of x q of x by Wronskian determinant d of x. These two integration you substitute and substitute in the we will identify particular integral. Now here example, if I take that same procedure, complementary solution I identified and u1 u2 identified, particular integral integrations and substituted, and both complementary plus particular integral we can obtain. Here also here Wronskian determinant I will identify, then I will substitute the integrations and c1 c2 plus I will substitute. Here non-homogeneous linear differential equations of the second and higher order with the constant coefficients, particularly we will be identify the particular integral is the main concept. Here homogeneous any complementary solution we are identifying, so that it is a particular solution we will identify the non-homogeneous. Non-homogeneous case here complementary solution and particular integral both will be there, both you should be identified, and both sum if we do, that is called as a general solution. Next in this operators how we will be used, because of type 1, type 2, type 3, type 4, all the cases we can be identify the finding of particular integrals in the non-homogeneous equation, and the variation of the parameters case directly we have that complementary solution in this c1 and c2, so we will be identifying the particular integral. So here integrations we will do and substitute in the c1 case and c2 case, then c1 into pi 1 plus c2 into pi 2 is a particular integral, then it is complementary solution, particular integral is called as a general solution. This is a overall idea about that what we have in this contents of non-homogeneous linear differential equation with the second and higher order with determining the particular integral. Thank you.